Hey everybody, how's it going? So we're going to take a look today at Bohr models. So if you think back to a few weeks ago, we talked a little bit about Bohr and his contribution to the history of the atom, and it turns out that the model that he created is pretty useful for describing some things in chemistry. So actually, if you look here in this picture, example of a Bohr model. So you have the nucleus here in the middle. Remember, the nucleus holds the protons and the neutrons, and like circles here around it, and they're called orbits or shells, and that's where he said the electrons sit. So it turns out that we can recreate these and pretty accurate for the first 18 elements in the periodic table. But yeah, let's take a look. Okay, so the Bohr model, it's a good way to represent the first 20 elements, and the electron, or the orbits, are shown as a ring around the nucleus, so sort of like what I said. An important thing to know is that the first orbit can hold a maximum of 2 electrons, and the second and third orbits can hold a maximum of 8 electrons. We're going to take a look at that in a bit to see why that is. It actually works out pretty well with the periodic table. That might be in another video, I'm not sure yet, but let's keep going. So the first thing you have to do is to figure out how many electrons the element has. So an easy way to remember that is to just look at the atomic number. So for example, hydrogen has an atomic number of 1, and it has 1 electron. Sodium has an atomic number of 11, so it has 11 electrons. So that's the easy way to remember. And then afterwards you place the electrons in their proper orbit. So we start with the first orbit. It can hold a maximum of 2. So if we had more than 2, then we would go to the next orbit, and that one can hold a maximum of 8. If we had more than that, then the next one can hold a maximum of 8, and so on and so on. But yeah, we're only going to be looking at the first 20 elements or so, so we don't have to go too far beyond that. So here's an example. So this one is for helium. Helium has an atomic number of 2. That means that it has 2 protons, and it also has 2 electrons. So you might be wondering how we know that it has 2 neutrons as well. Well, helium has an atomic mass of 4, and the atomic mass is the number of protons plus the number of neutrons. So if we know the mass is 4, and we know that there are 2 protons, then we know that there has to be 2 neutrons as well. And when you're making the Bohr diagrams, you always want to put the number of protons and neutrons in the nucleus. It's just a little bit of simple subtraction to do, so it's not too difficult to figure out. So let's take a look at another example here. This is neon. Neon has an atomic number of 10. That means that it has 10 protons and 10 electrons, and it also has an atomic mass of 20, so we can just do 20 minus 10 protons gives us 10 neutrons. Now when we're placing the electrons into the diagram, we're going to put 2 in the first orbit here, because it can hold a maximum of 2. But neon has 10 in total, so if it has 10 in total, we've already used 2. That means that there are 8 electrons left over, and we can put a second orbit here and place the 8 electrons in the diagram. You can also see how they're grouped in 2s there. That's usually how we represent the Bohr diagram. So yeah, just make sure that you keep the electrons in groups of 2 around the diagram. I have one more example here. This one is potassium. Potassium is number 19 in the periodic table, so it has 19 protons and 19 electrons. It also has an atomic mass of 39, so we can do some simple math. 39 minus 19 protons gives us 20 neutrons, and we just put that information in the middle. So our first orbit can hold a maximum of 2 electrons, which we see here. Our second orbit can hold a maximum of 8. So 1, 2, 3, 4, 5, 6, and 7, 8. Now we've used 10 electrons. We need 19 in total, so we need to add a third orbit, and we can put a maximum of 8 again. So 1, 2, 3, 4, 5, 6, 7, 8. Now that adds up to 18 electrons in total. Again, potassium has 19, so we have to actually add a fourth orbit and just place that last electron there. I'm going to be doing a video with a couple more examples and maybe some more explanation, an easier way to remember how to make Bohr diagrams. But that's it for this video. So if you guys have any questions, feel free to ask. Otherwise, have a good day. See you guys.